Alright, this is an optimization problem and just talking about it. Okay, the first thing you want to do is read and identify the problem which you were given. Okay, now taking a look at this actual problem and just working it out, you need to know what is given, what is unknown, and what needs to be found. So if you're making a box to hold the most amount of space, but you only know that the width of the box paper you're given is 14 inches, how much do we deal with, okay? Alright, so in looking at this stuff, you need to draw a picture. So we drew a picture of the box. We knew the whole thing was going to be 14, and if we took off two edges, it would be 14 minus 2x. So let me get rid of these circles. They are super distracting. Okay, because we're going to be taking off 2x's parts. Yep, let me get rid of that too. Okay. Alright, so just taking a look at this one. Minus 2x. Alright, so this is what it actually turns out to be. Alright. Okay, so this is what it turns out to be when we put it all together. Now we know that the length times width times height is actually going to be the problem. So if we plug in everything, we should be able to find the next part after we introduce the variables, which we did. We're going to write an equation for the unknown. So when we plug in everything right here, you're going to be able to find out, oh, this is pretty simple. We should have a pretty straightforward problem. It's going to be a variable. It's going to be volume equals 196x minus 56x squared plus 4x to the third. And remember, I'm distributing the x as soon as I do it. Okay, now what I'm going to do is the next step, which is test the critical points and endpoints of the intervals in the domain for the unknown. Now, I know I have to think about the intervals of what x could be. I know it has to be greater than 0. That totally makes sense. But I also know it has to be less than 7, because if it was 7, I would just have the two pieces of paper folded up to each other. Okay, I would just be cutting in this one part, and I really wouldn't have any width or anything. So I know x has to be less than 7 and greater than 0. So you could say this would be the interval of our 2 points, from 0, comma, to 7. And this is the interval you really want to think about for the variability of x. Okay. Now what you're going to do is you're going to do the derivative. Okay, and this becomes 196 minus 112x plus 12x squared. And so that's the actual point right there. Now if you notice, if I try to divide something out of each one of these, if I try to factor it out, because it always makes my job a lot easier to go ahead and factor, let me see. 196 divided by 12 doesn't come out evenly, but 196 divided by 6 doesn't come out evenly. 196 divided by 4 does come out evenly. So I can probably divide out a 4 out of all these. Now, for those of you guys at home going, oh, how do you know you could divide out 4? Well, if the last two digits are divisible by 4, you can divide out a 4. Okay? Alright, so it would be 49 minus 28x plus 3x squared. Okay, now we would have to go ahead and use, we would have to graph this to be, I'm sorry, not graph it, but we would have to factor it and just work it out across. Okay, and so when you get done factoring using the AC method, you're going to find out you're going to have 4 times 7 minus x times 7 minus 3x. Okay. Alright, now taking a look at this, we know our answers have to be between 0 and 7 inclusive. Well, if you notice this, on the zeros, my x would be 7 and 2.33 repeating. Okay, well, if you notice, my intervals, I can only take 7, and I have 7 as one of my answers, so I cannot include this. Okay, I can only take numbers less than 7. I'm sorry, I should have said that. So 2.33 is going to be a point of inflection. So what I do is I plug it back in to actually find out the max area. So I go 196 minus 112 times, parentheses, I'm going to do 7/3 just to get all those 3's in there. Plus 12 times 7/3 squared. Oops. There we go. Alright, so what I'm going to do is not plug this back in the derivative, but I'm going to plug it in for these x parts and find out what the actual volume will be. And so that volume is going to be 203.26 inches cubed. Okay, so that one's pretty simple to find the volume. Alright, but I'm also just trying to find x, and I'm finding out that x is going to be 2 1/3 of an inch. Okay, is what I'm going to cut off. Alright, and so that's actually how you find out to actually answer the question of optimization, is just finding it. It's a lot like linear programming, except you do it derivatives and then you do it with critical points. So that's the huge point of optimization. Okay, if you have any questions, please feel free to contact me. Otherwise, have a great day. Bye.